Venus, our mysterious neighboring planet, just 38 million kilometers away at its closest approach, closer than Mars. But unlike Mars, humans have never set foot there. Why? Because Venus is not just hot. It's a world where lead melts on the ground, acid rains from the sky, and winds can tear apart a spacecraft in minutes. The surface pressure is so immense, it would crush a submarine like a soda can. And yet, despite its deadly conditions, some dream of visiting. Space enthusiasts, futurists, and even scientists have imagined sending humans to explore its clouds, or building floating cities high above its boiling surface. But here's the truth that even most space fans don't fully grasp. Reaching Venus alive is effectively impossible with any technology we have now or might develop in the foreseeable future. In this video, we're going to uncover the impossible truths about Venus. Using insights from the brilliant physicist Michio Kaku, we'll explore why this scorching world remains forever out of our reach, and what that tells us about the limits of human space exploration. To understand why Venus is so utterly inhospitable, we turn to one of the most respected voices in modern science, Michio Kaku. Kaku is a theoretical physicist, futurist, and best-selling author, known for translating complex physics and space science into concepts the public can understand. Over decades, he has studied the possibilities and limits of human space travel. When it comes to Venus, Kaku doesn't mince words. He calls it a world that is, quite literally, hellish beyond comprehension. And while Mars might be a destination for future astronauts, he warns that Venus is a planet that humans are unlikely to ever touch. But we're not relying on opinions alone. Kaku bases his assessments on decades of scientific data collected by unmanned probes, including the Soviet Venera missions, NASA's Magellan radar mapping, and Japan's Akatsuki orbiter. These missions have painted a detailed picture of a world with crushing atmospheric pressure, toxic clouds of sulfuric acid, and temperatures so extreme they can melt most metals in minutes. The importance of authority here is twofold. First, it shows that the dangers of Venus aren't speculation. They are measured and verified. Second, it allows us to bridge imagination with reality. Kaku has a unique ability to inspire wonder about the cosmos, but also ground that wonder in scientific truth. He explains that while we can send robots to Venus, humans face a far more brutal set of obstacles. Every human-rated spacecraft we've ever designed is engineered for the vacuum of space or the cold, relatively calm surface of Mars, not for the searing, pressurized, acidic environment of Venus. By establishing this credibility, we can move beyond conspiracy theories and sci-fi dreams. This isn't about speculation. It's about physics, chemistry, and engineering limits. Michio Kaku provides both a cautionary and awe-inspiring perspective. Venus is a laboratory of extremes, a world that challenges everything we know about survival. Visuals, infographics showing temperature, pressure, and corrosive atmosphere compared to Earth. A short clip of Kaku explaining Venus's clouds. And here's a key takeaway. While some planets might be reachable with decades of technology and ingenuity, Venus is different. Its environment is not just hostile, it is fundamentally incompatible with human life as we know it. By understanding the science through credible voices like Michio Kaku, we start to see why some dreams of space exploration are limited not by imagination, but by reality itself. Confident, authoritative, informative, but still engaging and slightly provocative, setting the stage for the detailed breakdown of Venus's hazards. The first and most immediate obstacle humans face on Venus is temperature. Venus's surface averages around 465 degrees Celsius, or roughly 900 degrees Fahrenheit, hot enough to melt lead. To put that into perspective, the hottest oven on Earth barely reaches 250 degrees Celsius. On Venus, everything from metals to spacecraft materials can fail in mere minutes. Imagine standing on the surface of Venus. Before you could even take a single step, your suit's protective layers would start to degrade. Electronics, wiring, and structural components would warp and melt. Even the most advanced heat shields we've developed for spacecraft wouldn't last long under these conditions. The high temperature isn't caused by proximity to the sun alone. Venus has a thick atmosphere, rich in carbon dioxide, creating an extreme greenhouse effect. The planet traps heat like a cosmic oven, keeping surface temperatures hotter than Mercury, despite Mercury being closer to the Sunday. This heat also creates other cascading problems. Any robotic or human mission would have to contend with materials that can withstand not just 400 plus degrees Celsius, but also continuous exposure over hours or days. Air pressure and wind intensify the heat's destructive effect. Heat combined with acidic clouds, which we'll discuss later, accelerates corrosion and failure. Michio Kaku emphasizes that this is not a small engineering problem, it's a fundamental barrier. Even if we could invent heat-resistant alloys or cooling systems, the scale of heat energy on Venus is almost incomprehensible. A person or a machine that lands there without extreme shielding would be destroyed almost instantly. This is why all Venus landers to date were robotic, and even they only survived for hours before succumbing to the extreme temperatures. The Soviet Venera missions in the 1,970 seconds and 1,980 seconds, for instance, captured photographs for a brief moment, transmitting them back before melting in the furnace-like conditions. So, when we talk about reaching Venus as humans, the question isn't just, could we survive for a few minutes? It's, could we engineer a system to withstand nearly 500 degrees Celsius for hours, days, or weeks? And according to current physics, chemistry, and engineering limits, the answer is not yet, not even close. The extreme surface temperature of Venus is the first and perhaps most obvious reason why human missions are impossible. And this is just the beginning. In the next segments, we'll explore even more lethal hazards: crushing pressure, corrosive acid clouds, and hurricane-strength winds that together make Venus one of the most hostile places in the entire solar system. Informative, dramatic, and slightly alarming, designed to make viewers viscerally feel the danger while grounding it in science. After temperature, the second and perhaps most terrifying obstacle on Venus is atmospheric pressure. At the surface, Venus's pressure is about 92 times that of Earth. To put that into perspective, it's like being 900 meters underwater or more than half a mile deep in the ocean. Any human attempting to walk on Venus would experience a crushing force equivalent to nearly 1 ton per square inch pressing down on their body. Even the strongest submarines on Earth are designed to withstand pressures far less than this. Imagine trying to design a spacecraft or a pressure suit that could survive not just minutes, but hours in this extreme environment. Every material, seam, and joint would be stressed to its limits and beyond. This pressure is why every Venus lander has been robotic, and even then, they only survived briefly. The Soviet Venera 13 lander, for example, was designed with thick titanium walls and heavy-duty insulation, but it lasted just over 2 hours before being crushed by the environment. That's with no humans inside. Visuals. Archival footage of Venera 13, landing and transmitting images before shutting down. Michio Kaku often points out that the pressure alone makes Venus fundamentally uninhabitable for humans. Unlike Mars or the Moon, where astronauts can walk on the surface with heavy but manageable suits, Venus's pressure would instantly destroy a human-rated spacecraft without enormous engineering innovation, something far beyond our current technology. And the problem compounds when we consider Venus's high temperature combined with extreme pressure. High heat weakens materials, while pressure crushes them. Together, they create an environment where failure is almost guaranteed. Even the most advanced alloys and composites we have today would struggle to maintain integrity. In essence, Venus's atmosphere is a natural barrier. It's not just hostile, it's physically lethal, and it's the reason that any serious human mission to the surface remains science fiction. Even if we could solve the heat problem, the crushing weight of the atmosphere presents an entirely separate challenge that cannot be ignored. So far, we've seen that Venus's surface temperature and atmospheric pressure alone make human survival impossible. But there's more. Next, we'll examine the corrosive atmosphere, a lethal cocktail of acid clouds that would attack both humans and machines alike. Informative and suspenseful, designed to make viewers truly grasp the sheer physical danger while keeping the science clear and grounded. The third major obstacle to human exploration on Venus is its corrosive atmosphere, a deadly cocktail of chemicals that would destroy humans and machines alike. Venus's clouds are composed primarily of sulfuric acid. That's the same acid found in car batteries, but in concentrations far higher than anything humans routinely encounter. A drop of this acid hitting bare skin would cause severe burns almost instantly. And for spacecraft, even high-grade metals and electronics are vulnerable. Exposed circuits can corrode in just a few hours. Michio Kaku emphasizes that this isn't a minor nuisance, it's a major engineering nightmare. Any human-rated mission would require materials resistant to sulfuric acid at extreme temperatures and pressures. Current alloys, ceramics, and coatings degrade too quickly, making the design of a functional Venus lander extraordinarily difficult. And it's not just the clouds. Venus's thick atmosphere carries corrosive gases, including carbon dioxide and traces of toxic sulfur dioxide, which further attack metals, electronics, and protective coatings. Even robotic probes succumbed quickly. The Soviet Venera landers, despite heavy shielding and titanium plating, could only survive a few hours on the surface before corrosion, combined with heat and pressure, disabled them. Another complicating factor is that the corrosive atmosphere is highly dynamic. Acid droplets can form and evaporate repeatedly, and winds distribute these corrosive particles across the planet. Even if a spacecraft attempted to shield itself, it would face continuous chemical assault. The challenge becomes even more impossible when we combine this with the previous hazards: the surface temperature and crushing pressure. Corrosive clouds at nearly 500 degrees Celsius and 92 times Earth's atmospheric pressure create a perfect storm of lethal conditions. A human could not survive. Electronics and materials would fail, likely within minutes, even if engineered with today's most advanced technology. Visuals: composite animation of temperature, pressure, and acid clouds interacting destructively with a spacecraft. Michio Kaku often points out that this is why all Venus exploration has been robotic, and even that is extraordinarily difficult. Venus is not a planet we can terraform, suit up for, or colonize, at least not on the surface. Any human presence would require miraculous breakthroughs in materials, science, technology that does not currently exist and may never exist. In short, the corrosive atmosphere is Venus's third insurmountable barrier. It attacks every material we rely on, putting humans and machines alike in extreme danger. Next, we'll explore another deadly factor: super-rotational winds and violent weather, a force strong enough to tear apart even robust spacecraft. Informative, dramatic, and cautionary, designed to make viewers feel the chemical hostility of Venus while understanding the scientific reasoning behind it. The fourth major obstacle humans face on Venus is extreme winds and violent weather conditions that make survival or landing nearly impossible. On the surface, winds may seem relatively slow, averaging only about 25 kilometers per hour. But don't be fooled, these winds are blindingly destructive when combined with the planet's heat, pressure, and corrosive clouds. A spacecraft or human suit exposed to even these moderate surface winds would face constant abrasion and chemical attacks. The real danger, however, lies in Venus's upper atmosphere, where winds reach staggering speeds of up to 360 kilometers per hour, 224 miles per hour, faster than a Category 3 hurricane. These winds rotate around the planet in just 4 Earth days, a phenomenon called superrotation. Visuals top-down animation of Venus's super-rotating clouds circling the planet. These winds create violent turbulence, enormous shear forces, and dynamic weather systems unlike anything on Earth. Any floating platform, robotic drone, or hypothetical cloud city would be constantly buffeted and stressed by these extreme forces. Even worse, These winds can transport corrosive particles and superheated gases around the planet, exposing every structure or spacecraft to continuous chemical and thermal attack. This is not just a theoretical problem. The Soviet Venera probes experienced such conditions, which contributed to their rapid failure. Michio Kaku often emphasizes that this combination of wind, heat, pressure, and corrosive clouds makes Venus far more hostile than any other planet we visited. It's not just about landing, it's about maintaining structural integrity in a constantly punishing environment. Even the best materials known to humanity would eventually fail. The weather also includes lightning and extreme atmospheric convection, adding yet another lethal layer. Lightning storms on Venus are intense and frequent, posing a direct threat to electronics and any conductive surfaces. Combined with the already toxic clouds, this makes the surface environment not only uninhabitable, but actively hostile to human technology. In summary, Venus's extreme winds and violent weather represent yet another barrier. They complement the heat, pressure, and corrosive atmosphere, creating a planetary environment where human survival is virtually impossible. Next, we'll examine another factor that adds to the lethal mix: radiation and proximity to the sun, which further complicates any human mission. Dramatic, cautionary, and immersive, designed to make viewers viscerally feel the destructive power of Venus's weather while understanding the science behind it. The fifth and final major obstacle to human exploration on Venus is radiation exposure, amplified by the planet's proximity to the sunday. Venus is closer to the sun than Earth, receiving nearly 1.9 times more solar energy. While this contributes to the extreme surface heat, it also increases solar radiation levels, especially in the upper atmosphere. Unlike Earth, Venus has virtually no magnetic field, which means it cannot shield the planet's surface from cosmic rays and solar flares. Even in the upper atmosphere, where temperatures and pressures are somewhat more manageable, radiation levels are significantly higher than on Earth or even Mars. This poses a major risk for any human mission, as prolonged exposure would cause serious health damage, including radiation sickness and increased cancer risk. Michio Kaku notes that radiation is not just a health risk, it's an engineering challenge. Electronics and spacecraft systems must be heavily shielded to survive, which adds mass, complexity, and cost. The higher the radiation, the thicker the shielding required, making any human-rated Venus mission even more difficult. Solar flares are another concern. These sudden bursts of energy from the sun can deliver massive doses of radiation in minutes, which could easily overwhelm spacecraft shielding and endanger any astronauts. Unlike deep space missions, where magnetic fields or distance from the sun help, Venus offers little natural protection. When we combine this with Venus's other lethal hazards, heat, pressure, corrosive atmosphere, and winds, the radiation factor becomes yet another insurmountable barrier. Even if humans could survive minutes on the surface, extended exposure to Venus's radiation would make a longer mission essentially impossible. This is why Michio Kaku calls Venus a planetary dead zone for humans. No amount of imagination, ambition, or incremental technology can overcome the combined lethal effects of Venus's environment. Any serious exploration must rely on robotic missions, orbital studies, or high-altitude floating platforms far above the deadly surface. In short, radiation and solar proximity are the final critical reasons why Venus is effectively impossible for human exploration. It's not just one deadly factor, it's a cumulative effect of multiple extremes, creating a planet that remains firmly beyond human reach. Informative, cautionary, and immersive, highlighting the full spectrum of dangers and reinforcing the impossibility of a human mission to Venus. So, after exploring Venus's extreme temperature, crushing pressure, corrosive atmosphere, violent winds, and deadly radiation, one question naturally arises: could humans ever get close to this planet and survive? At first glance, the answer seems obvious. No, not on the surface. But that hasn't stopped scientists and futurists from imagining possibilities further up in the atmosphere, where conditions are less extreme. Michio Kaku has often spoken about floating cities in Venus's upper atmosphere, approximately 50-60 kilometers above the surface. Here, temperatures range from 0 to 50 degrees Celsius, and the pressure is similar to Earth's surface. In theory, humans could live in airships or cloud habitats, floating above the deadly surface below. But even this safer zone comes with challenges. Constant exposure to acidic clouds still requires protective shielding. Super rotational winds can push floating cities at hundreds of kilometers per hour, demanding advanced stabilization systems. Radiation from the sun is still higher than Earth, requiring additional shielding for human life. This raises an important question. Are we chasing the wrong dream? Many discussions about Venus involve terraforming or human colonization, but the reality is stark. The planet's surface is effectively inaccessible, and even the upper atmosphere presents immense engineering challenges. Michio Kaku uses Venus to highlight a broader truth about space exploration. Not all planets are meant for humans. While Mars sparks visions of colonization, Venus is a reminder of the limits of human adaptability. Understanding these limits doesn't quench our curiosity, it enhances it, pushing us to ask, if we can't survive Venus, what does that tell us about the range of planets humans could realistically explore? Are robotic missions ultimately more effective than human exploration in extreme environments? Could floating cities in the upper atmosphere serve as a stepping stone for learning how to live in alien worlds? The tension lies in the contrast between human ambition and planetary reality. Space has always inspired dreams, but Venus is a planet that forces us to confront the harsh limits of survival, physics, and engineering. It challenges our imagination, asking us not just what can we do, but what should we do. In short, Venus is a planet of impossible extremes, but contemplating it opens up new scientific, philosophical, and engineering questions about humanity's place in the cosmos. Curious, thought-provoking, slightly provocative, designed to make viewers reflect on possibilities while emphasizing the scientific reality and the limits of human exploration. After examining the extreme heat, crushing pressure, corrosive atmosphere, violent winds, and deadly radiation, one thing becomes clear. Venus is effectively off-limits to humans. No spacesuit, no spacecraft, no engineering breakthrough we currently have could allow a person to survive on its surface. Yet, there's a deeper lesson here. Venus is a planet of extremes that pushes the boundaries of our imagination, forcing us to think critically about space exploration. It reminds us that while humanity dreams big, science imposes real limits. Not every celestial body is meant to be walked on, colonized, or tamed. Michio Kaku often highlights that understanding these limits is not discouraging, it's empowering. By knowing where we cannot go, we can focus our curiosity and creativity on what we can explore safely and sustainably. Robotic missions, orbiters, and high-altitude floating habitats offer a chance to study Venus without risking human life, allowing us to learn, discover, and dream responsibly. So, as you think about Venus, ask yourself, what does it mean that some worlds are beyond human reach? How can we balance our desire to explore with the realities of physics, chemistry, and engineering? And how can studying Venus teach us about our own planet and the fragile conditions that make life on Earth possible? In the end, Venus challenges our dreams, but it doesn't limit our curiosity. It's a stark, beautiful, and deadly reminder of the forces at play in our solar system and the importance of respecting those forces as we reach for the stars. Venus may be impossible to conquer, but it is impossible to ignore. By studying it, we not only uncover the secrets of a neighboring planet, but also the limits and possibilities of humanity itself. Reflective, awe-inspiring, slightly provocative, designed to leave viewers thinking deeply about the extremes of Venus, the limits of human exploration, and the power of scientific understanding.